afternoon, everybody. Hope it's nice wherever you are. It's Rainydan back for more puzzle game creation. And if you haven't watched the series already, we've been doing this inside of a system called Gas City. Gas City is AI agent orchestrator. You tell it to do things, and then it goes about its business. That's the main idea. And so, earlier videos in the series, earlier streams, we've been talking about the basics, how to get such a city up and running. And now we're doing hands-on to try and get our city to do something interesting. So I've taken the challenge of coming up with new Nicoli type 2D pencil puzzles. These are fully logical puzzles that you take the given information and then you can, you never have to guess, and there's always one unique solution. And so we're trying to see if we can not just make such a puzzle, but make the team that's going to make the puzzle, give them the business processes that they're going to follow so that they make the puzzle correctly. And I think the interesting thing about this, uh, it's got to be that we're not sure if we have the right business processes right now. And in fact, we've seen some, shall we say, infelicities in what's been created for us so far. But that doesn't mean we didn't make progress. And we're going to take what we learned and refine it. And this refinement process is what's going to turn our team into a well-functioning, smooth-running machine. So, where we were last time, if you recall, we were running this catalog ingestion formula, and the first source that we were looking at was, I think, Nicoti puzzles. And so we had the mayor doing that. We sort of hit cliffhanger, and we're going to see what it made out of this. We've captured 7 lessons. News to me. All right. And here is it working. Phase by phase, starting from this. It did this as a WISP, which is an ephemeral formula, you could say. We have 2 choices for creating formulas and turning them into workflows. One of them is to, let me see if I can get this echo to go away. Yeah. One of them is to make each single step in the workflow, each node in the task graph, its own materialized bead. And the second way we can do it is to just do sort of one big bang workflow. This is sort of assumes that it's going to be handed off to a single actor working a single bead, and it's going to do all of the steps inside of that formula, step by step. So that's what it did in this instance. It's like the mayor is our only workflow agent. Okay, so what did it do? Or what's it doing, rather? We can start with that. So we can look at this workflow itself as a refresher. It's going to do these several steps here. Visit the source, build a list of puzzle types, write an entry for our catalog. Our catalog has various description of each puzzle that it's learning about. It's going to review it for completeness, merge it from staging into entries, and then release the session. And I think it's done a couple other steps. I think I saw like phase 6 and 7 inside of the, and there might even be more steps in this formula, and maybe the documentation wasn't refined yet. Oh, I see. And we also noted that there are a bunch of sub-steps inside of these steps. So in the language that these workflows are written in, we have some like input parameters, and then we have steps, and this is the survey step. And we can see if we scroll down to another step, there's a draft step that depends on our survey step. But survey is actually an umbrella for a number of different things that are happening. Survey includes this and this and this. And so one of our big questions for the mayor today is like, On reflection, would it have been better to rewrite this in terms of these substeps being their own reified steps that also need to perhaps be categorized and take their dependency together, um, so that the next group of steps can depend on this group of steps and that kind of thing? And there's reasons that you might want to do that. Um, for instance, like if all of these were individual beads that were working into like canonical working spaces, they could be parallelized potentially. So let's see what it got up to. It's working on survey. Um, it wrote something to the Nikori staging run. It only did Slitherlink, which is one of the more famous Nikori puzzles, if you want. It's about making one big loop. All right, and then we have write the staging entry for Slitherlink. Make it the model. And so it wrote 100 lines about Slitherlink in our schema, our specified schema. It wrote merge notes. It reviewed itself. It noted that it's partially done because it's done the first one. As a were, I, I didn't make a video yesterday, but I did go through some puzzle catalogs and had a definitely good time. In particular, looking at let me cite it correctly. Um, must be, yeah, World Puzzle Foundation Grand Prix. Um, you can sign up for this yourself if you want. Yeah, we'll drop a link in the chat. Um, but yeah, they, besides being sort of a like a rated puzzle competition, they have like a large set of puzzles that they run in their competitions, and they also have examples for that. And so, besides going through historical puzzles, which you can totally do, looking through their archives, and learning new puzzle types that you may never have seen before, they also have a database of examples of types that you should prepare to solve well if you want to compete in the competition. And the next one is coming up in May the 15th to 20th, it looks like. Something like that. Well, that's for Sudoku only. May the 29th to June 3rd in Japan. Cool. So it won't interfere with Grand Sumo, which is starting this weekend again. You're running for 2 weeks. Anyway, total sidebar. But yeah, I was enjoying some new puzzle types, and if we get time, I think like certainly a side project would be to go through all of those, add that to the sources, and go through those puzzles as well. And I think there's also a sort of keep in mind that like the tasks that we're doing right now is we're trying to build our repertoire so that we do something that's genuinely novel, right? And we're not trying to pay homage to these necessarily, or rip them off, reskin them, or anything like that. We are trying to draw lessons from them potentially, about how differentiated are the structures of what feel like novel puzzles. We're going to have to lean on my intuitions about when a puzzle feels novel or when it feels like just a sort of like, oh, that's just another kind of Sudoku, or this is much like Hakudo, but it's a triangle instead of a square, or something like that. Um, and that has happened from time to time as I've been going through some of these new puzzle types and test puzzles. Okay, so let's see. I'm not sure what I understand about bugs in the formula. Uh, Holding opinionated changes for your call. Thank you, I guess. Ah, maybe it's talking about it wants to make sure it's starting to refine the process inside of the formula because it hasn't gotten the results that it wanted to after it tried to follow the procedure that it wrote, which is funny, of course. Um, but I think that's a good thing. It's like this is definitely something that would happen in a regular software company where the process that we run starts to refine itself the more that we run it and the more that we uh, you know hit an instruction that turns out not to work exactly right. Like we would love to make our processes so smooth that of course they can be automated, but at least so smooth that they can be followed without error. End state. We've got an entry for Slitherlink with a substantive formalism, some deduction techniques, sources, and audit comments. Lessons surfaced. Catalog entries doesn't exist on a clean rig, fixed in the formula, so it adds that directory if it needs to. Review verdict template used .agent name, which doesn't substitute at cook time. Fixed to use GC agent or unknown. So this, it's going to like look in the environment for a GC agent variable to set. And I assume that that's set when you spin up an agent. I don't know if that's true. It thought that this would work. That's all I know so far. Source name is used verbatim. Multi-word source names will produce paths with spaces. Needs your caller. Caller slugifies versus formula slugifies. I think it should probably add the underscores. Drain step doesn't fit a manual walk. Okay, so when it's doing it, yeah, there's no controller session to drain. Sure. Ah, interesting. I authored the entry from training data without fetching the URLs. So this is a really, really funny. This is like what a world, what a time we live in, kind of thing. Um, I think that it's like I've read this already. I know what's on that page. I don't need to go and look it up again. It hasn't changed. This is such a weird idea to me. I think that imagine if your brain was so big that instead of searching the web, you just remembered everything. That's kind of what it did here. And I think that I'm really if you don't go and read the web page and do your own stuff, you're relying on number one, the reliability of the reconstruction of this thing. But two, you're also relying on the reliability of the training of the model itself. Right? And as a developer, just paying for it, um, that part is it's not exactly a black box because I could potentially with lots and lots of time and effort, in principle, do exactly what it did. And it would go and read this web page and it would, memorize those tokens and remember what it needs to remember. Um, but I think that for precision or for something where little details matter like this, where a slight, you know, um, each one of these puzzles has a really small rules kernel, right? And perturbing that rules kernel a little is going to take you way off course in trying to re-implement it, trying to analyze it. Um, Honestly, I think that for something this small, it probably should go read the web page again and just see if it's right. Just imagine if it went, oh, you're absolutely right. I did forget a crucial detail out of the Slitherlink page, and yeah, cool. Yeah, let's talk about these. Fixed. Okay. Um. Oh, there's one thing that we didn't do though, which is critically important. Before we start typing back at it, which I already tried, but um, let's look at what it actually did. So I've been holding off on reloading this directory until now, but we have staging runs, which I assume it's going to keep adding to that. But it would have had the slitherlink MD in the staging folder and then moved it over when it was ready. Okay, so this is what it learned about slitherlink. It's a loop. There's a rectangular grid, although this is sort of a it can be relaxed. Like I said, there are variants of this that have just lots of other kinds of grids. Find a single non-self-intersecting closed loop set for every numbered cell. Exactly that many of the cells, and again, not four, but bounding edges lie on the loop. Equivalently, assign each grid edge a Boolean value, loop or not loop, subject to three constraint families. Per vertex parity, every grid vertex has degree 0 or 2, which will cause it to loop. There's a global single cycle. Set of true edges forms a single connected cycle. Yeah. Every numbered clue with cell with clue k has exactly k of its boundary edges true. A and B decompose into local constraints amenable to per cell propagation. That's talking about how you can just write the numbers and you know what's happening in that little area, but then C is what gives it its long-ranged character. Slitherlink does not require this cycle to visit every cell node. That's true. You can kind of you're not required to go to every dot in the grid in Slitherlink. Yeah, notable clues: 0 anchors, 3 adjacency. Yeah, 1 3 in the corner. Certain corner clues. Single loop forcing. Partial loops have to be reachable. Yep, and there's a few implementations of it as well. Cool. Now, is this true? Do they make pictures? I don't know if that's true, but triangular, hexagonal, and region are treated as separate entries. Interesting. The puzzle's Japanese aliens, Takagaki. Is a historic name. That's interesting. All right. Interesting why it did that. It's, I think, helpful that it talked about triangular grid. Um, Maybe we should be adding something about variance. Okay. Piece of feedback. The formula each few pieces of feedback. I found the overall result helpful. Understand Slitherlink. I sort of believe, sort of buy, that we will be able to summarize other puzzles this way. The formula is written with substeps inside of its steps. makes parts of this workflow that could potentially be parallelized into linear blocks. Let's consider the pros and cons of making each as many steps as possible parallelizable. So here I'm not telling it that, oh, you're wrong, and every step should be, parallelizable and declares dependencies and stuff like that. Which I'll say forces, which forces parts of this workflow could potentially be parallelized into linear blocks. Well, let's consider the pros and cons, make as many steps as possible parallelizable. I think the other reason why this is important, here I'm going to put on a little shoulder warmer here, is that asking it to sort of one shot a complicated process rather than doing it in this say more automatable, more deterministic fashion. It's sort of asking for the cognition to perhaps get something wrong. Okay, there we go. Sorry if this looks crazy. Just been having some shoulder trouble lately, and this is what I've got. Let's see how weird it looks. Just look at myself here. Okay, that's not too bad. It's fine. No problem, right? And I'll get nice and toasty. I know it doesn't feel. I look out the window. It's a beautiful day. Doesn't feel like I should need extra heat, but yeah, it's just for my poor little shoulder. Okay. I'm not trying to force it to do it my way. I want it to tell me why it would or would not be good for it to leave it like this. This is sort of like this Chesterton fence thing. I don't want to force it to remove the fence if I don't know why it put it there. And it would be nice, of course, if I'm right and if in the long run we're not building sort of workflows that have one long step that has 50 different little sub-steps in it. And I think too, I see. I think too that how do I put this? We're going to be making a lot of workflows. We're going to be writing a lot of formulas. And we want to get the patterns down now, the meta patterns of how to write a good formula. And we'll do that by writing in good formulas and iterating on them until they are strong, robust, And that way, we won't see this sort of lazy pattern when the next mayor session comes along and says, "Oh, you need me to write a formula? Let me look at the ones that we've already got. I'll see what we are doing." Right? And this is sort of like a really common theme, common thing to happen if you have like a junior engineer, this kind of thing. Is that they're just going to go look at the examples and do whatever is there. So we want our examples to be really tight. Substeps inside of it. Steps. Did we have any other feedback on this formula? We will have to test whether we can continue to ingest new puzzles in a similar style where the formalisms might collide if they do in fact overlap. we want to be able to detect that. In that sense, we are not just describing math, we are doing taxonomy. Let's think a little bit about that as we add more examples. Okay. Let's see. Oops. Oh no. Don't do that. I keep doing this wrong and scrolling wrong. Okay. Bug 3. Regarding bug 3, let's decide on some canonical source names that have the spaces replaced with underscores. And add a step to look up the canonical name when we need the source name or path or other use. We can store the canonical source names and add to that list. We pick another source. We add another source. Okay. Friction 2. That's an interesting problem to have, the S1. Oops. Fine. Okay. Friction 2. I go back. Let's see. The problems with writing puzzles out of training data are twofold as I see them. Maybe 3. And we already discussed this a little bit. 1, relying on model training data to capture all necessary details about a puzzle type. Relying on model reconstruction of those accurate reconstruction of those details from the data. 3, puzzles out of training data as I see them, puzzle entries. Verifying details from a canonical source is a gold standard for Um, small changes in the details might make big changes in our understanding of the rules or underlying mathematical formalism. And to honor the community and make a good puzzle. I was gonna say game, but yeah, and make a good puzzle. We want to make our best effort to understand what it is. Really novel. Against that, we might have some benefits. It might be hard to interpret the live page, and the model representation might already be better. It might be hard to interpret the live page, whether because it is more visual or because the description is not great. The the rules are actually stable, unlikely to change. Five. The cognition to reconstruct details might be more expensive than just reading the page. The rules are actually stable and likely to change. Hmm. 6. The puzzle type might be obscure enough or similar enough in name to another puzzle that the model might have learned. Might not have learned all details. We are not narrowly concerned very obscure puzzle type. Is that true? I was going to say something like the more obscure a puzzle type is, the less relevant it is that we happen to be reinventing it. And obviously, like, that's not super respectful to the community. But also, maybe less obviously, is that I think that I'm thinking about how to phrase this. even if something is obscure, it's not like we want to rip it off. um, but I was trying to think about simultaneous invention the way that a human would think about it, and go, well, even though somebody already invented this, it's okay for me to reinvent it. Um, you know, if it was so obscure for me that I couldn't find it or even reference it, then it obviously couldn't have played into my acts of invention, right? That would be true for me personally, but I don't think it's true for this agent. Say that it says that it's bringing me something new, and it's actually something that was rattling around in an obscure corner of the internet that should have been in our catalog and wasn't. uh, that's a big problem. And I think that the reason that we're going to these lengths to not just try and talk about names or publishers or popularity, or we're trying to get down to these mathematical formalisms, is because there's probably just a lot of untapped ground. And my intuition is that, yes, there are some overlapping mechanics and things, but if we get far enough out on the edge, we're not going to collide with anything. We're going to put together a couple of things that haven't been put together before, or we're going to, take it in a new direction. Ideally, make new mechanics and use those as the building blocks for our new puzzles. Um, there's some other aspects to making a commercial project, like I when I was looking through, I've been talking about this sort of like pipe to pipe game that's in mobile. You can. It's not exactly Pipe Mania. There are some other ones later that have been like uh, connect all of these colored pipes together, fill the whole grid. Don't let them, overlap each other. No pipes can cross each other's color. That kind of thing. Um, I think that's Numberlink. Yeah, I was looking at puzzle types, and you know, Nicody did Numberlink a really long time ago, and but that's not the version that is like selling well on the phone, right? The phone is kind of like user friendly. It has touch controls. It's kind of pretty, you know. It has undo. It has reset. Um, and that's another sort of dimension of creating like a puzzle type product. Um, as far as I know, the rules of puzzles are not copyrightable. that's, but this isn't about like just staying within the four corners of copyright law. It's definitely about trying to make something new and not stepping on all of these greats that have come before, but learning from them and then taking it to the next level. That's the goal. Okay, so we're trying to sort of take its side. Um, it might be hard to interpret the live page because it's more visual or because the description is not great and the model representation might already be better. That might be true. Like I looked at the page for Nikori for some of its puzzles, and they are very terse at times. They might have like a one sentence description and like a one picture sample puzzle or sample solution or something like that. Um, and so from other sources that have talked about Slitherlink all across the internet, um, you might develop a more three-dimensional picture of it, so to speak. Uh, so it's definitely possible that the model representation is already better. Model representation might already be better because it leans on multiple sources. On multiple sources. Multiple sources. Mm-hmm. Expanded on the material and such. The rules are actually stable and unlikely to change. The source web pages we chose might be canonical, but less than helpful. but less helpful than, e.g., a scholarly discussion of the same game. What else can we sort of give them? I've heard this called steel manning as well, right? Like, if you want to do the opposite of making a straw man argument, you make the argument that you're opposing as strong as possible. That way, if you defeat it, then you tend to believe that your argument is strong. And if in the course of that you sort of change your mind, then that's even better. You changed your mind. So other benefits of going straight to the model instead of the page. I think that's pretty good. I feel like there was at least one more thing I wanted to mention. It's the schema one. Suggest replacing the example with a fictional type. It's just an interesting. It's not. This situation is not going to last forever. I don't think this situation of needing a unbiased example is going to last too long. As we add entries, we can refine the example. Simple. When we actually invent a novel puzzle, we can make that our example. I think it's better to confine ourselves to nonfiction. Okay. Talk to me about the pros and cons of reading the web page in order to refine or disconfirm what we already know about the game from model knowledge. Alrighty. And it is kind of telling me, hey, you could be saving a lot of tokens if you clear out this conversation. I think once we're done with talking about this, then we can start a handoff, and then we can move on to ingesting more of the puzzle types into our catalog, refining our formulas, and then refining our catalog entries. Certainly with the goal that we'll get this catalog done. We'll be able to start analyzing it for patterns. We're going to be finding overlaps and doing our taxonomy. And then potentially we will be able to move on to actually making something. Like we'll be giving enough fodder to the inventor. They'll be able to perhaps invent a new game. It is kind of waiting for me as well. Like way up in the conversation, it said something about, hey, are you ready to invent a game yet? Tell me how the puzzle works, or what your concept is, or whatever. Which is a reasonable question. And I think that's a reason why as well. I've been spreading myself out to looking at some of the puzzles in the Grand Prix because I'm familiar with a number of them as we go through, maybe under different names. But the more of them that I know, the more I'll be able to say, oh, okay, I don't want to come up with a mechanism that's already been done or something like that. There isn't exactly a while we're waiting, but I think that there is another file that it was working on inside of the catalog. So we've got staging, and we didn't really look at this yet. All right, let's look through these for a minute. We're going to do lessons learned. So this is the table that it showed to me. Yeah, I think that the changes to the antiquarian prompt are fine. I'm sure that the mayor will have something to say about what we're saying. Hmm. Okay. All right. So pretty much what was in the um, session. All right. Okay. So it's I'm just reading this page like you um, about the pros and cons of being simple orchestration outside of the Wisp, or one could say inside of the larger workflow. A is overkill until we need formal DAG join semantics. Yeah, that's fine. We haven't had a source that ingests failed partway through. Okay. Great. Yep, B3, that's fine. Let's keep it going. Okay, cool. So it's trying to talk about where we're learning about puzzles from. Um, for well-known puzzles, everything is fine. For obscure puzzles, it definitely goes off the rails. For visual, poorly described canonical pages, um, there's this sort of combination that we can do. Yeah, add a verified from. That's good. Good. How is Claude doing? I think Claude's doing pretty good here. 3 confirmations. Um, yes, yes, yes. Um, I think Claude's doing good. So let's start with that. Um, yeah, yes. I concur with those recommendations. Um, um, wanted to let me add that I concur with the suggestions above to enhance the antiquarian prompt as well. I forgot to mention that. While we're doing this, let's see if I can find an interesting puzzle for us to look at. Okay, that's fun. Just so you can kind of see what we're up against. I don't think there's anything funky to see in my previous Firefox session, but yeah, not so much. This is fine. All right, so this, if you go to the World Puzzle site, the archive, they have the instructions and the competition puzzles for all of their competitions going back to 2014. So Sudoku, I would think has been going. No, they started Sudoku the same year, 2014. Anyway, so yeah, why don't we go through this for a little bit while we're waiting? Yeah, still working hard. Yeah, so we have puzzle authors and then a puzzle type. So here's Nerdy Kabe. This has been made into a pretty popular mobile game. The grid is divided into regions. Cells are in the same region if they're adjacent horizontally or vertically. So this is fairly familiar. It would be especially familiar to people from Southeast Asia who play the game of Go. It means that the regions are basically, you know, groups inside of Go, right? If they're connected horizontally or vertically, then they're all one big group. And in that game, it's important because they actually share liberties. They act as a team. And it's important in that game because you have to surround a group in its entirety in order to remove it from the board to capture it. Anyhow, you can see how we start with a grid like this, and also says each given number is in a white region that has the same area of cells as that number. So some Go group, some region of 4, is going to go through this number right here. And then all black cells are in the same region, and no 2 by 2 group of cells can be entirely shaded black. So it would be illegal to shade like these 4 together. And then for the answer, they're trying to make it so you don't have to type in the whole thing. Just they have these sort of checksums in this competition, where they're like enter the length of the black segments from left to right. So in this row, there's a black segment of 5. In this one, there's a black segment of 3 and then 1. And in this one, there's a 1, a 1, and a 1. Right. So yeah, immediate observations like we can't connect together these groups that have 2 different numbers on them, because it would imply that any island that included them would have to be both 3 and 4. So we could do things like this has to not be filled in. And these 2 squares also have to not be filled in. But if these 2 squares are not filled in, we need to extend this 4 island over here. So this one has to not be filled in. And you can kind of continue solving like this. One interesting thing about this corner, right? We reach as far as we can with this 4. We go, oh, I wonder if this is going to work. Here, no, it didn't do it. It didn't do what I wanted. I was really hoping that we could just start coloring on this whole thing and writing. Maybe here. Yeah? Yeah? Okay. Yeah, okay. Let's count out 1, 2, 3, 4. There's no number, there's no island. We're not allowed to make up new islands either. They're all numbered, see in the solution. And so there's no island that could reach out to here. It's too far away. You could reach out to here with this 4. You reach out to here, but not here or here. And now we look at our other rule. No 2 by 2 cell can be entirely shaded black. So this has to be in the island somewhere. Just use circle for that. There's only one island that can reach it, really. It's this 4. So this is definitely part of that 4 island. And also, since we know that this is part of that 4 island, there's really no way to get out to this square anymore, because there's no set that will take us from here, here, and here, and here. That's 5 cells is too many. So yeah, pretty much the only ways you could do this are going sort of this way or in the middle. And so it's not possible for anything to reach up here. Is this fun? Is this theme fun? I find this fun. But, you know, there's lots of people that might not, that might say, oh, you know. I guess what I really love about this genre is that, you know, even though these rules are very simple, we've got islands, we've got numbers, we've got sort of rivers, if you want, is another way to interpret this. But we've got no lakes of 2 by 2. You know, even though we've got these, oh yeah, this couldn't possibly be taken. 2, 3. Can't get to here. Sorry, you can see how distracted I'm gonna get here if I allow myself to. Here's an interesting inference. If we X out right here, then the 3 island is gonna go this way. We definitely wouldn't be able to get to here, and there'd actually be no way to get to here either. So that would cause a 2 by 2 hole in our puzzle, and we can't have that. So this one's got to be taken. For similar reasons why we're reasoning about how far the 4 can reach, the closest to this is this 3 over here. We can't reach into this corner. Nothing can reach into here. Another thing that's interesting about this particular puzzle is that say that the 3 were here and here. After we've completely used up all of the numbers in this island, we have to put ocean or water, black, next to this thing. So it would look like this. So let's use a notation I often use. Let's pretend that this is actually part of the 3 island. This would also have to be, because it's the only way for this piece of island to be connected. And then this, if we extended the 3 island anymore, then it would get too big. We would have to do this. And because we couldn't double back around, we have to go this way. And that would cause this to happen. So here, we've made a hypothesis, and we've followed it until we derived a contradiction. And the contradiction is that this 2 by 2 area would have to be all black, a square. And so, in fact, it's not the case. You know, this has to be crossed out. And then we would go back and erase all of our marks here because that hypothesis didn't pan out. And we try a new hypothesis. And over time, as you get used to this puzzle type, you start forming more and more convincing hypotheses, perhaps. Here's an interesting one. If we put the, and I know I'm looking at the solution here, you know, but I'm trying to just reason from whatever I've put in the grid so far. If we put a island here, we know it can't be part of this 3 at this point because that would make it too big. So it would be cut off. We can't make it part of the 4 because the 4 is going that way. In fact, we can already like X this out. So if we put the dot here, and then here, we would make our 4 island, but we would have cut off all of these black pieces from all of the rest. And there's a rule that says all black cells must be in the same region. So we would know that you can't do this. And by the no 2 by 2 rules, we'd have to put a 4 here. And one of these remaining ones is going to be our winner. Sorry, got really distracted by this puzzle. Let's see. So keeping in mind that oh, here we might actually this. Oh shoot! Undo. We can only change all of our marks at once. We can't like make a rainbow of painting colors. Ideally, that's what we'd be doing. Oh, here's another observation. We cannot cut off. Oh, oops. It's all good. We can't cut off. Okay, let's be marking. Not sure why it's not just letting me mark, but maybe it has something to do with. We definitely can't put one here because that would cut off this spot from all the rest of the black. So that implies that we're I'm not sure what it's going to take for me to get back to drawing here. Just let me draw. Okay, we can trash can that one. And we could We know that this one actually has to be there. This one can't be there. Obviously, like Adobe is not like the ideal connection here. All right. If we extended this island down here, then it would cut off this little piece of black. So that won't be extended either. There we go. We're getting close. We've almost finished all of the... Oh, okay, here's an interesting one. We know that if this is cut off, then we won't be able to put anything in this one. So it can't be cut off because that would make a 2x2 square. So here's part of the 3 island. And we only have really these remaining spots for the 3 island. We could always try, we only have 2 options left for this 3, which implies that we could do sort of a hypothesis. I wonder if I can start a new drawing. Oh. Anyway, so we've been doing Narakabe for maybe too long. Sorry about the digression from the programming. However, we needed to spend at least 5 minutes on it. So, oh, whoops, I did it again. Okay. Summary of what changed. We added formalism class. We added verified from. Formalism class is interesting, right? We're kind of when you train a classifier, generally you're trying to label things into their appropriate classification. And maybe they overlap or whatever, and so you give things 2 labels. But one odd thing about that is that if you have a strictly enumerated set of labels, then you can chunk different things into their bucket. And you know that like they have to have at least one of these buckets. But in what we're doing, say that we come across a puzzle that doesn't have a seed value, doesn't have a word in the controlled vocabulary, it doesn't seem to match with what it's doing. We're going to have to grow our vocabulary. And then we might have to think, should I apply this vocabulary to all of my previous entries? Should I reclassify them? Because before, maybe I was classifying them at a certain level of granularity, or I only had these 7 choices. And now I've added this 8th one. Maybe that will be better for one of the other ones. So what we're doing is sort of exploring and growing our labels as we're classifying. Maybe I'll talk to it about this a little bit. Use source slug, that's cool. Yeah. Training derived. This is the word that it wants to use for knowledge that was in the model. So I'll try to remember to call it training so that we're both on the same page about that. Good. One more idea that came to mind is about formalism labeling. We have some seed values, but it seems like we will grow that list from time to time. I would think it would happen when our existing labels are inadequate to describe the formalism we find in the literature or by analyzing the mathematical structure of our game. What criteria should we add? Should we use to add another formalism? When we do add another formalism, should we reclassify existing entries? Also, I'm not sure. I think it is clear, I think, in the discussion that something could have a couple of formalisms. Maybe we should add this advice. Feel free to criticize this idea. Wow, it says I've had this thing on for almost an hour. Is that true? All right, back to the riveting puzzle content. We were trying to figure out how to draw on a page without selecting the existing drawing to move it. Okay. Well, so if you recall, these smaller marks, they're not really there. They were part of a hypothesis that was like a road not taken. We're going to get one of these from this 3. That's interesting because it kind of implies that there's no way that we could put our 4 island down this way because we'd eliminate both of these squares. So we'd actually want to, oops, come on now, X out this one. And if we do that, then we've got 3 X's, and to avoid the 4th one coming in here. This is the last part of the 3 island. That means this is a real X right here. Yeah, so to recap, this 3 island is, it's this over here. This is our island. And that is in fact what's in the solution. It's not a coincidence, it is a logical thing that would happen. So the way that we're figuring out the next part is we've got this black area out to here, but it's almost all surrounded. This is the last spot where it would get surrounded. If we put the 4 island right here, then it would enclose this black area away from the rest of it. So we're following our rule number 1, 2, I guess 3. All black cells must be in the same region. This has to be an X right here. If that's an X, then we actually know where our island is. It's right here, and here, here. That means that we know this is an X. And finally, this is our last spot in the island. Here we go. So we actually solved an example puzzle, example Norikabe, and it does match the one over here. Hopefully all of the inferences that we were making made sense along the way. That's the goal. Is in fact, I mean, we shouldn't use a reasoning principle that could sometimes be wrong. This will occasionally happen when you look at a puzzle type, you think about it for a bit, you come up with some rules, but it turns out one of your rules is mistaken in some circumstance. All right, it finished that a little faster. The catalog grows monotonically. The antiquarian is stochastic. Yeah, yeah, right. It's more like labeling, not just one formalism. Yep. Different deduction families are forced, not different specific techniques. So the links 3-3 and Heyawake's region completion are both inside their own classes. Ah, okay. Yeah, yeah. So it's talking about generalizing mechanics. And if you're too specific, you're like, well, Slitherlink is all these unique mechanics. It has that thing where two cells are both three next to each other, or Nurikabe has that thing with the 2x2s, and nothing else has that. Uh, but there are general things that we can take away from them that also might overlap. Ah, yeah, yeah. If it's already in the academic or constraint programming literature, that's really great. Good, good, good. I think this is all really good. And I think there's an interesting question here, which is let's meditate for a second on this discussion. Did anyone ever have this discussion before? Do you think that this is in the training data somewhere? I mean, we're talking about trying to classify puzzles, which, there may be some papers about that or something. We're not referencing them as we talk, but we are kind of alluding to something that somebody might have done. Um, but this isn't stupid. It does seem to be like we're kind of right at the limit of my personal understanding. Yeah, triangular slitherlink. I think that's cool. Same class. I agree. That's my intuition as well. Um, I guess the reason I bring that up about the nature of the conversation is that it's showcasing the power of these models, even if it's not 100% new. Obviously, it's following me where I want to go. It's pushing back on what I told it to push back on. Yes, use multi-class membership. Yeah, exactly. There's going to be a lot of these puzzles, hopefully, where we're like, oh, well, this is this combination with this and this and this, and there's just going to be gaps. We're going to enumerate all the combinations on all the popular puzzles. It's a combinatorial thing that could have been smashed together in many different ways, and we're going to find lots of ways that nobody ever did, you know. And maybe they will suck, or maybe they will be unfun, or we won't figure out how to put those two mechanics together, or there's something about their shape or something that either makes them impossible to combine, or we're not clever enough to come up with the parsimonious rules that will cause us to get those mechanics or something like that. But I think that's not going to happen. I think that we are going to be able to. It's sort of like when memristors were developed. So this is like an electrical engineering thing, which again is not my bag, but it was sort of like they were looking at a classification like this of different, I want to say like parts of a circuit, if you want. I want to say transistor was in there. Uh, the fourth fundamental circuit element, alongside the resistor, the capacitor, and the inductor. Yes. And so again, I don't know that it is. I don't know that much about this, but the short version is that there seems to be a theoretical symmetry between the resistor, the capacitor, and the inductor, and there was a sort of missing piece in the puzzle that would do kind of the fourth thing that those three things were not doing. And so he inferred that there would be another circuit element called the memristor. Has a dynamic relationship between current and voltage, including a memory of past voltages or currents. And let's see, I think it was difficult to actually study it. In 2008, so it was invented though. The scientist who was thinking about this theoretical symmetry wrote the paper in 1971, and 40 years later, in 2008, a team at HP Labs found experimental evidence for it based on analysis of a thin film of titanium dioxide. I guess, yeah, there's some controversy back and forth about who invented it when, you know, when should it actually be considered to exist? Is there an ideal memristor, that kind of thing? Why am I talking about this? The reason I'm talking about this is that with so many game mechanics and puzzle types, we're definitely going to find combinations in this manner where we look at that spot in the chart and there's nothing. There is no game that did X and Y and Z. And we can write that game. We can invent that game. And so it's a way to find targets for our design. Okay, sorry about these digressions. I was talking to somebody this week, and it turns out it's something I do a lot. uh, Doing a digression in order to make a point, apparently a verbal tick that I do a lot. Make a reference or refer to a conversation or an event in my own life, and then eventually we'll get around to the point, or I'll forget what we were talking about. One of the two. All right. Refinement, renaming, or discovery. Yeah, that is a trade-off. It has to, right. Geez, I was about to do it again. My linguistics professor was talking about this trade-off, the trade-off of classification, and it's more like a trade-off in general about we might call generalization. So he was a linguistics professor, and at the time I was going to school, Chomsky's X-bar syntax was the way to think about diagramming sentences and what is the underlying structure of English and that kind of stuff. Um, and he had an alternative take that was like sentences are more like molecules, and there's a ion on this side and there's a base on this side, and they want to come together. They want to, one of them is seeking the other, and you can kind of diagram your sentences that way. And but he was talking one day about the different refinements that have been done to Chomsky and syntax over the years, and the problem with what they were doing, I guess, was that they keep wanting to expand their theory to cover more and more special cases. So to understand how clauses move, like when you have a sentence that has the word which, um, like this is the way I think about syntax, which is the wrong way to do it. Um, you know, that kind of sentence. They were they kind of broke their syntactical models a little bit because they're sort of referring to um, something. It's hard to understand what the word which is referring to. Is it the whole sentence? Is it a certain thing in the sentence? And they'd have to do a lot of fancy dancing and relabeling of words and diagramming of hierarchical structures and stuff to get that. And his point about that was that basically the more details they cover with their new theory, the more weird additions they would have to make. Because language is like fractal, right? It has a fractal boundary of what's grammatical and what's not. Um, it goes very deep, I guess, to decide like what's you could say what's colliding and what's not. There's a lot of fine classes, if you want, inside of language. And if you try to write a theory that generalizes across a lot of exceptions, then the theory itself starts to get complicated, right? It starts to mold itself, or maybe even you could say overfit to this sort of training data. And if we had a more general theory, right, then it would allow us to say sort of grander things about the language, but it would become more inaccurate down at those like specific instances where it breaks. And that was his idea basically, was that you know the more specific you get, the more you're losing these generalizations. And that's sort of what the robot is talking about here. I don't know if this is a PhD worthy observation exactly, although, that's my personal association with it. Um, yeah, there's no static answer to how fine. Would two entries in the same class be duplicates worth comparing? And I think it's going to be interesting to see if we're going to run into a lot of puzzles that are actually like at a mathematical level, like reskins of each other. We'll see. Yeah. Apply. Okay. Yeah. That's it. Good. I think that's a good strategy too. The multi-labeling. I agree about the multi-labeling. I generally feel that if we have a small set of labels as building blocks, we will be able to use them to find novel designs by finding building blocks that have not been combined before. And maybe this is a good inventor strategy. Um, go ahead and make the edits you suggested. All right. Again, this is are we doing Gas City right now? It sort of feels like we're doing, single threaded Claude code right now. uh, you know, we're not farming out a whole bunch of stuff to a bunch of different agents, you know. We're not directing traffic. It's not getting like busy. Um, I feel that will start to happen though. We're kind of trying to bootstrap from nothing, and so in my mind, like getting these sort of founding documents or founding processes right Um, that is going to serve us well in the long run. I'm just reading the edits as they go right now. That'll save us a little time. Cool. Okay. Which file is that edit for? In the schema. Okay. You know, this is of course I am programming in English by talking to the mayor, but the mayor is programming English by writing down messages inside of the catalog schema. Um, I guess we've all been programming English for a long time by, you know, writing Word documents and procedures and stuff, um, and getting our colleagues to read them and follow them. It's English all the way down until you get to until you get to the executables, and then it's math all the way the rest of the way. Okay, lits, Lits. So the LITS tetrominoes, for reference, that would be L I. That's 4 cells there. D. I guess they're all in the picture too, except for S, huh? S. Right? Shade exactly 4 cells to form an LITS tetromino. All the shaded cells are connected. You can see how that's true in the answer. No 2 by 2 can be shaded black. We saw that already in Nurikabe. 3. When two tetrominoes in adjacent regions share an edge, they must not be of the same type, regardless of rotations or reflections. So you can see in this picture how an L is next to a T, is next to an L, is next to a T. This L is next to an I, which is next to the T. All right. So, what can we do with this? Well, one interesting thing about this is that all 4 or all 4 cells in the tetromino, they have to be contiguous. And then that means they have to be in the region. There's a kind of squeeze thing going on here. So imagine that we were starting from here, this end. We'd have to go 1, 2, 3, 4. We'd have to fill in these 4. We started from this end, we'd have to fill in 1, 2 at least. And we started from this end, 1, 2 at least. So no matter where we start from, we've got to fill in this. Let's try doing that in some of the other ones. 1, 2, 3, 4. 1, 2, 1, 2. Got to fill in this one. And by similar reasoning, 1, 2, 3, 4. 1, 2, 3, 4. And then this one. So this one has to be filled in too. Okay. Can we do that for this one? This is a long linear one. It actually can only start from these two ends. 1, 2, 3, 4. 1, 2, 3, 4. Similarly for this one in the middle. These are the middle two. Oops. I don't know what my mouse is doing there. 1, 2, 3, 4. This one's a little weird. It's sort of like, can you imagine a scenario where you avoid any of the cells? And you can imagine avoiding these two by doing these four down here. You can imagine avoiding these two by doing these four. You can imagine avoiding these two by doing these four. So we actually can't mark anything just based on starting from an end and squeezing, you know. Okay. Let's see what we got next. We start to do things like no 2x2 can be black. Do we have any relevant places for that? It means it can't be both of these, for instance. Couldn't be both of these. Couldn't be all three of these. Both of these, both of these. There's no way for this one to be avoided either, is there? 1, 2, 3, 4. There we go. I don't know if that'll totally help it. Maybe. Another way to do that. Imagine that this was blank, right? Can you get a 4 tetromino into this? No. So it can't be blank. And similar for this. Imagine this was blank. Yeah. But you can actually imagine that any of these cells in the middle one were blank. The next one we might want to consider, all shaded cells are connected with each other. That's interesting because it implies that like if these two were unshaded, then I'd have to, well, and these two would be shaded and this would be connected to this. We're sort of looking for areas where the shaded areas might be cut off from each other. And oh, this is interesting. Connected with each other. All the ones in the example are connected to the group by at least one edge. But it is ambiguous whether they can be connected at a corner only, like that. It's not covered in the example. There aren't that many places to draw an eye in this puzzle. Can't be done in the center one because there's no 4 in a row. There's here, here, here. We want to be considering this rule 3, the same type rule. I guess one interesting way to put this is what types can we get out of these shapes? What letters? So this one with the bend in it, we've got these 4 options. We can't do a T and we can't do an S. So it's got to be L or I. Maybe that'll be significant, maybe it won't. This one, we could do this S, this L, or this I, but there's no way to do a T. This one, we can do an L, this L, or this S, but we can't do a T or an I. T or L, but no S. And finally, here we've got no S again. T, I, or L. I'm just, yeah. One interesting thing about making these two meet, for instance, is that if this one isn't an I, probably has to be an S so that it can meet this one. because if this were an L, it would get fairly cut off from the other pieces, and then this one would have to be an L to meet it down around this corner. I've never done this particular puzzle type before, but we could slowly learn it. Let's see. All right. I'll let it land it cleanly. Okay, great. That looks good. Next, you describe a puzzle type. I'll run it through novelty check. Well, also, we're going to go fill out our catalog. There used to be a handoff command in Gassity that would allow it to hand off to the next mayor session. Well, I think I'm probably going to call it there. I think what's coming up next is we're going to try and actually fill out our catalog some more, and we're going to shake out our taxonomy. So that'll be next time. But hopefully you enjoyed a couple of puzzles while we were waiting for the mayor. Maybe I got a little too tired there, sorry. But we'll always come back for more. I'll see you soon.